Hi, this is Klaus again from Electronics Unmessed. In previous videos I introduced a tool that you can use to predict the benefit of thermal insulation. Today we go ahead with our step-by-step user's guide. I will explain how to map temperature control and we will see interesting results again. In the last part of our step-by-step guide, we dealt with the climate data, which are of course very important parameters for our energy consumption predictions. In this part, I want to show you how to map the temperature control in the house. And we demonstrate with interesting examples that the behavior of the people who live in the house plays an important role in the heat energy consumption. Of course, our tool does not replace the expert for your house renovation, but you can use it to make a good estimate yourself, which does not cost you anything. There is a lot of know-how about heat flows derived from temperature differences in the tool. It makes difficult calculations easy for you. But I have already explained all that. I will link you to the earlier videos on the top right. By the way, there will be more videos for the step-by-step instructions. So stay tuned and subscribe to the channel. And off we go with the temperature and heating control. Again, we use our example house with 4 floors: basement, ground floor, first floor and attic. I will show you later how other houses can be modeled, because there are other types of houses for which you might want to make insulation benefit predictions. So, now let's start with entering the target temperatures. We consider day and night separately, since one would like to have different temperatures at night and during the day. Or we even want to switch off the heating completely during the night, for example. Yes, you can switch the heating and air condition on or off on one floor here on the left. The target temperature corresponds to what you see on your heating thermostat. This temperature is enforced by your heating or air conditioning in the respective room. Of course, this consumes heating energy, which we can predict. The target temperatures are currently set at 20 degrees Celsius at night and 22 degrees Celsius during the day. It is a common setting, at least in Europe. From this, our tool calculates the total energy consumption of 120.8 kilowatt hours per square meter per year, which is actually quite a lot. I chose the example so that I can show you how insulation improvements can have an effect. First, however, we would like to see whether we could save energy simply by optimizing the target temperatures a bit. We set the target temperatures at night to 17 degrees Celsius. In summer, you could also set the target temperatures a little higher, depending on the months, but we simply use 17 degrees for the whole year. During the day, we leave the target temperatures at 22 degrees in the 3 summer months, and in the rest of the year we go to 20 degrees Celsius. Okay, this simple measure would reduce our annual consumption to 94.8 kilowatt hours per square meter. That alone would save us 26 kilowatt hours per square meter, which corresponds to around 22%. That's quite a lot, isn't it? But it's not really that surprising, because if you use a lot, you can also save a lot. Now you could have the idea of turning off the heating completely at night on the upper floors to save even more energy. Instead of trying that over the year in your house, you can predict it with electronics.unmasked. First, we turn off the heating in the attic during the night. Now we see something interesting that I want to point out. One of the strengths of this tool is that we get an immediate prediction for the temperatures in the attic if there is no heating or air conditioning. And this also shows that our tool not only calculates the thermal energy flows to the outside, but also the thermal energy flows via false ceilings and through unheated rooms. And this is important because a relatively large amount of thermal energy can flow through the false ceilings. Okay, what are the results? The temperature in the attic drops to 12 degrees in winter. That could be tolerated, but the additional energy saving would be only 4.3 kilowatt hours per square meter. So next we investigate what happens if we also turn off the heating on the first floor during the night. Okay, with that we could save an additional 9 kilowatt hours per square meter. But in the attic it gets pretty uncomfortable at 6.8 degrees at night in winter. In addition, there may be a risk of frost on an extremely cold night. Of course, we don't want that, so we prefer to heat the first floor all night again. Incidentally, we could also use this to calculate the outside temperature at which frost would occur in the attic in this scenario. We are now at an energy consumption of 90.5 kilowatt hours per square meter per year. The saving of heating energy would be about 25%, and we achieve that without any investment in renovation measures. Of course, this does not replace modern thermal insulation, but you can obviously save a lot of energy by your own behavior. Here we simply quantified it. Now we have 3 more interesting features that we can easily toggle on or off. And there are also complicated calculations behind these functions, which I will explain to you in detail later. In our example house, electrical devices are running, which of course produce waste heat, which additionally heats up the building. Let's take a look how that works. I just switch electricity on here. Wow, that's more than I thought. After all, the consumption of heating energy is reduced to 81.7 kilowatt hours per square meter. Of course, this is only the case in a relatively cool country like Germany. In a warm country, it would increase energy consumption, as more energy would then be used for air conditioning due to the additional heating. By the way, we will take a closer look at the settings for the switchable functions later in a separate video. Next, we have 2 natural heat sources, the sun and the people or animals that live in the house. Let's add the influence of the sun. In our example, we reduce consumption to 73.8 kilowatt hours per square meter. The sun can obviously make a significant contribution to heating energy. Again, this only applies in a relatively cool climate zone. In a warm climate zone, additional energy must be used for air conditioning to compensate the sun's contribution. A human gives off around 60 to 100 watts of heat power. With our switch here, we can take that into account or not. This would theoretically save us a few more kilowatt hours. In practice, however, ventilation is also required when people are present, and as a result the energy is lost in cold climates. In a hot climate, it is even double counterproductive because you have to ventilate more and you need to compensate the waste heat from people as well. And that was the second part of our step-by-step user's guide. We calculated how much heating energy could be saved per square meter by just reducing the target temperatures. The tool also calculates thermal energy flows through rooms that are not heated or air conditioned. And it even calculates the temperature in these rooms. We have also seen the influence of waste heat from electrical devices, people in the house and the sun. I find that very interesting because it allows you to calculate realistic scenarios quite well. I hope you had fun. If there is any questions about this part, please ask in the comments. I will be happy to answer. In the next part, I will talk about how to enter the properties of a building. I will explain how the areas of walls, windows, doors and insulation values etc. will be considered in the tool. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.